Number patterns. The very simplest form of a number pattern is a repeating pattern. Here are two examples. In this pattern, you can see that the 5, 4, 7 is repeating. So after this 5 would come another 4 and another 7. In this pattern, we have 3 digits repeating also. 1, 3, 1, 1, 3, 1, 1, 3, 1. This is the very simplest kind of number pattern that there is. But there are also patterns called growing patterns, where the thing that we are repeating is the operation that we are doing to each number before. So in this case, we don't have any digits repeating, but we do have it growing by adding 3 to each number before. So 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 3 is 18. So the thing that we are repeating is adding 3 to each of the previous digits. And then here's another growing pattern. In this pattern, it's a times 5 pattern. So we are multiplying each of the previous numbers by 5 to get the next number. So the thing that we are repeating in this pattern is multiplying by 5. You need to be able to analyze a pattern, like this one for example, in order to tell what the pattern is, in order to describe the pattern, and to be able to tell future numbers, further numbers in the pattern. So let's go through some steps that you might follow, that you might ask yourself in order to analyze a pattern like this, and then we'll try it on the next slide. So the first thing that you're going to ask yourself, are the numbers getting bigger or smaller? As you go from left to right, do the numbers get bigger or smaller? So if I look at this one, I start with 2, and my numbers are getting larger, 4, 8, 16, 32. So these are numbers getting bigger as I go left to right. The operations that make numbers get bigger are addition and multiplication. If the numbers had been getting smaller as we go left to right, then we would know it had to have been a subtraction or a division pattern. But since we see that the numbers are getting bigger, we know that it has to be either an addition or a multiplication pattern. Next, we're going to ask ourselves, what can I add to the first number to get the second number? If we had seen that the numbers were getting smaller, then we would have said, what could I subtract from the first number to get the second number? But since our numbers are getting bigger, we're going to go with what can I add to get the second number. So I'm going to ask myself, what can I add to 2 to get 4? Well, I could say 2 plus 2 is 4. I'm going to hold that in my brain. I'm not done yet. Then I need to ask, does this work if I continue it? So I added 2, 2 plus 2 made 4, 4 plus 2 does not make 8. So that does not work. So I'm going to go over here to where it says no. And then I'm going to try multiplication. Going back up here, if it had been a smaller number, a pattern getting smaller, and subtraction had not worked, then of course I would try division. But now I need to try multiplication because I've proven that it's not an addition problem. I can't add 2 every time to get to the next number. So now I'm going to ask myself, what can I multiply this number by to get the next number? Well, 2 times 2 makes 4. Let's keep trying times 2. 4 times 2 makes 8. 8 times 2 equals 16. 16 times 2 equals 13. So, because all of the rest of the pattern works, we know that this is a times 2 pattern. And if I were to find the next number in the pattern, I would multiply 32 times 2 and get 64 as the next number. So these are the questions you should ask yourself as you analyze some patterns. Let's use those questions to analyze these examples. So first thing I want to know, is the pattern getting bigger or smaller? The numbers are getting bigger as I read left to right, so this has to be an addition or multiplication pattern. So I'm going to try addition first. 8 plus what is going to give me 13? Well, 8, if I count up, I'd count up 5. So 8 plus 5 is 13. Let's try plus 5 as we go across. 13 plus 5 equals 18. 18 plus 5 equals 23. So it is a plus 5 pattern. To get the next number, I would add 5, which would be 28. In the second pattern, I'm seeing that the numbers are getting smaller as I go left to right. So this has to be a subtraction or a division problem. I would ask myself, 2,400 minus what is going to give me 1,200. If you can't do that in your head, then you can subtract these two to find the difference. And that will tell you what you would subtract to get from here to here. So I'm going to do that. I'm going to subtract these two. And that tells me that 2,400 minus 1,200 would give me 1,200. Well, if I continue that subtraction problem, I'm going to ask myself, does that work? Is 1,200 minus 1,200 600? No, that doesn't make any sense. So it's not a subtraction problem. So I'm going to erase that, and I'm going to get rid of that idea, so it must be a division problem. So then I'm going to think 2,400 divided by something to give me 1,200. Well, let's try an easy number. Let's try 2. Is half of 2,400 1,200? Yes, it is. Then I'm going to divide by 2, and that makes 600. 600 divided by 2, or broken up in half, is 300. So 300 divided by 2, the next number would be 150. And finally, down here, first I ask, are these numbers getting bigger and smaller? They're getting bigger, so it has to be an addition or multiplication pattern. Then I'm going to say 2 plus what gives me 8? 2 plus 6 gives me 8. Does plus 6 work on the rest? 8 plus 6, that would only equal 14. So it's not an addition problem. It must be a multiplication pattern. Now I'm going to say 2 times what gives me 8? Well, times 4. And then I'm going to check to see if times 4 works for all the rest of the numbers. 8 times 4 is 32. 32 times 4 equals 128. And so in order to get the next number, I will multiply by 4. 128 times 4, I would get 512 as the next number. There are two very common mistakes that fourth graders make that I want you to watch out for. The first one is that, let's see, say for example this one. I often have I see fourth graders who go, oh, 2 plus 6 is 8, and they don't even check anything after that. They think of the very first way they can get from the first number to the second number, and they don't check the rest of the numbers, and they don't see that if they continued that pattern they thought this was a plus 6, it's not going to work for the rest. So be sure you check the pattern all the way throughout. The second, and probably the most common mistake actually, is that you're often asked on problems like this to give the next number, but sometimes you're asked to give let's say the 7th number or the 5th number in this pattern. And when that's asked, you want to count from the beginning. So let's say you were asked to give the 7th number in this pattern. This would be the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. In order to get this problem right, you'd have to go 2 more times and say the 7th number in the pattern. So be sure that if it's telling you a certain number in the pattern, be sure you count from the beginning and name the correct number that it's asking for. And finally, I'm going to show you 2 tricky patterns that you might see similar ones in the future. In this pattern, I see that it's a growing pattern. It's getting bigger, so it's got to be addition or multiplication. Now I'm going to check addition first. 1 plus what gives me 2? Well, plus 1. Then I'm going to say, does plus 1 work? Well, 2 plus 1 does not give me 4, but 2 plus 2 gives me 4. Let's continue with addition and see what happens. 4 plus 3 gives me 7. 7 plus 4 gives me 11. 11 plus 5 gives me 16. So as you can see, this is an addition pattern, but we're adding 1 more every time. Not the same number every time, but 1 more. So next we would add plus 6 here, which would be 22. So notice that you can, you don't have to add the same thing every time. You can change the number that you add, but it's still a pattern. Here I see that the numbers are getting smaller as we go left to right, so it has to be subtraction or division. Let's try subtraction. 100 minus 10 is 90. Well, minus 10 would be 80. So this, from 90 to 75, is actually 5 more, minus 15. Here it's minus 20. Here it is minus 25. So I hope you see 10, 15, 20, 25. The next thing we would subtract is 30. So the following number on this pattern would be 0. So this is a subtraction problem that's subtracting 5 more every time.